Hi everyone, Dennis Foley from Acoustic Fields. We're going to talk about the nonsense of noise. Speaking of the nonsense of noise, I'm filming these videos in Arkansas, and we just had a air raid siren or public service siren going off because of Harvey, I guess, a test or maybe an actual situation. So how appropriate. Noise must be qualified. Noise must be quantified. We must know frequency and amplitude of any noise that we're dealing with. That's why we have a system where we do a 7-day noise time study. So you measure the noise outside the source, in this case a siren, and you measure the noise levels inside the room. That tells you how well your barrier is working, okay? And what you need to do to improve upon it. So there's direct correlations in this, and science is really important. So the barrier is a direct response to the frequency and amplitude of the noise that you have to stop. So we usually talk about noise when we're talking about frequencies less than 125. There's a lot of techniques in the marketplace right now that'll help you deal with noise above 125, but don't mistake them. That 2 layers of drywall, green glue, double wall construction, that is all about frequencies above 125. Won't do anything for you below 125. So make sure that you have the correct barrier technology and look at the test data on whatever you're trying to do after you get your noise measurements. Here's the critical part. Once you get your noise measurements, your frequency and amplitude, designing the correct barrier, that's the hard part. And there's not a lot of literature that'll tell you that. So I'm going to give you a few tips right now to help you out. Let's say we have a 40 cycle wave of energy coming at us, and it's plus 15 dB, so it's big, it's powerful, and we want to build a barrier so that maybe on this side we get plus 2 to plus 3 dB bleed. Hear the siren? We're going to run through it so you can we can get this done for you. If my hair starts blowing, then we're leaving. So we have to design a barrier that's going to stop the 40 cycle energy that's really large here. So now we're in the vibrational acoustics because our airborne energy is now in the air and striking a surface. Density, construction methodology, and thickness are all the variables we look at. So if we're going to use a multi-layered approach in our barrier, which we always do, then every material we use has a frequency and amplitude. And that's the hard part. And only experience and testing will give you that ratio that you usually need. I'll give you a tip up front. The lower the frequency, the higher the density of the first 2 layers. So that'll give you an idea how us engineers process things. But we can help you with this. We have a lot of experience. All our rooms are measured for frequency and amplitude and vibration. So we have a real good sense of what construction methodology works for what frequency and amplitude of noise. Remember, noise is difficult. It's not the same science as you're used to with absorption and diffusion with airborne energy. It's vibroacoustics. We're taking airborne, making it into a vibration that goes through surfaces, and you have to apply different kind of science to it. And the key to understanding those 2 disciplines is in their overlap. Hope this helps. Don't let noise get you. Thank you. Thank you for watching this video, and if you liked it, please give us a thumbs up. We also have a newsletter that you can subscribe to, so please do that because we offer special price discounts to only those on our newsletter. And then don't forget about our forum. We have started a forum on our own website where people ask questions, and I usually get a chance every couple of days to look at it. There's an interchange between people on the forum, and we'll give you real answers on a regular basis, so that'll help you. Thank you.